Okay, D here, I've copied and pasted the question, the diagram from above because it relates to this. D, the maximum frictional force between masses small m and big M is mu capital N, where mu is the coefficient of static friction between the pair of masses, and capital N is the normal reaction force on mass M. Show that the maximum amplitude of oscillation A, for which the mass small m will not slip, is given by that expression, where k is the spring constant and g is acceleration due to gravity. Okay, this is a bit of a tricky question because it deals with concepts that are not covered in high school physics. So, not in New Zealand anyway. So we need to look at a couple of terms and just describe them or define them. So this coefficient of static friction, we need to get a little bit of info about that first. So coefficient of static friction mu is a sort of a modifier which changes the amount of force required, because you hear about friction, but friction force is different for something that is static, that is in a fixed position as we have here, compared to something that is moving. So you have static friction, and you have you'll also have a coefficient of kinetic friction, or moving dynamic friction. That's probably the word. So once something is moving, it'll have a different level of friction, and that coefficient just modifies it. So this coefficient mu modifies the normal force, okay, to give you the actual force of friction in this situation. So since it modifies the normal force is also small mg in this case, because your normal force is the reaction force upwards, and small mg downwards is the actual force. So what we're dealing with here then is the force that would be used to slide the m. So the minimum force required would be your coefficient of static friction times by small m times by g. So because mg, again, as I said, is the normal force. So this is the maximum force, frictional force on mass m, beyond which if you increase, you will cause it to slide. Okay, so what we need to know is this greater than the accelerating force, which is ma from our force equals mass times acceleration. So that's the force of acceleration, this is the force of friction, we'll call it. So that's what this investigation is kind of